In this video, we will be continuing our walkthrough on exercises 1.2 of Mr. John Coburn's Precalculus. This is going to be part 3 of the exercises 1.2 walkthrough. If you haven't watched the previous videos, basically they comprise of the answering of these questions. Make sure to check them out if you want to start from the scratch, if you haven't watched it yet, or you basically want to start from the scratch. You might want to start with part 1. And yeah, we'll continue with part 3, that is answering from numbers 71 to 78. So let's start with number 71. Without using a calculator, find the value of t in open bracket 0 to pi close parenthesis that corresponds to the following functions. So the first thing that we're supposed to take note of is specifically, generally speaking, we know that in a usual or in a particular xy that is written in this specific fashion, we know that x is cosine theta and y is sine theta. So in the context of trigonometric functions, this is something that you have to take note of. And so upon acquiring this knowledge or applying this knowledge, for number 71 we have sine t. So basically sine is y, the y value. So we have something like this. And so our missing value is x. And in order to find that, we know that this value or this y value is located in quadrant 2. What do we have in quadrant 2? We do have to apply this illustration or diagram. We've been using this a lot of times in the previous videos, in the previous questions, and we're going to use it again. I'm sorry about that. For number 71, so in quadrant 2, sine is sine and its inverse cosecant are both positive. Therefore, it is you can say that the y value is positive. It has been in the beginning. There is no negative sign. So obviously, these two ideas work together. They're not contradictory to each other. So right now, what we want to know is that in the unit circle, a usual pi over 6 would have the points square root of 3 over 2 over 1/2. And pi over 4 would usually have the points square root of 2 over 2 and square root of 2 over 2. And for pi over 3, pi over 3 would have the points 1/2 and square root of 3 over 2. You have to take note of these. All of these will serve their practical usefulness in answering the following numbers. So right now we know that because the y value is square root of 3 over 2 and the x is unknown, we could say that this is pi over 3. So the missing value is 1/2. Before I deleted what I annotated earlier, I hope you've taken note of it. So this is pi over 3 in quadrant 1. But because our number 71 is situated in quadrant 2, the pi over 3 in quadrant 2 is 2 pi over 3. you might think that I'm saying random numbers, but if you've memorized the unit circle, um, it shouldn't serve any confusion. You should already understand the unit circle by then, right now. If you haven't memorized the unit circle yet, please do not watch this video. It's just going to be a lot more confusing. It's best to know the basics first, which is the memorization of the unit circle. Then you can make applications. This video is all about the applications on the unit circle. So, for number 72, given that cosine is 1/2, so that's our x value, and the y value is missing. So we are in quadrant 4, which means, let's first find out that this point specifically is already pi over 6. I'm sorry, this is pi over 3. Similar to number 71, pi over 3 is usually 1/2 as the x value, and the y value would always be square root of 3 over 2. And so for quadrant 4, we need to look for pi over 3 in quadrant 4. What is that? In the unit circle, this is pi over 3 in quadrant 4. 5, 7, 11. 5 pi over 3 is the pi over 3 in quadrant 4. So this is the final answer. Alright. Let's move on to number 73. So given that cosine is negative square root of 3 over 2 and the y value is missing, which is the sine t value, we know that this point is situated in quadrant 3, by which quadrant t, x and y are both negative. And that because the x value is a usual square root of 3 over 2, we could say that this is pi over 6. Pi over 6 has has square root of 3 over 2 and 1/2. And because we are situated in quadrant 3, we need to look for pi over 6 in quadrant 3. Now, just to make an easy illustration, so this is pi over 6 closest to the x-axis, and this is 754, if I'm not, I think I can recall it correctly. 2, 3, 5, 7, 5, 4, 5, 7, 11. 1, 1, 1. So this is 7 pi over 6. Seven pi over 6 provides these two values. Alright, let's move to number 74. So given that sine t is negative 1/2 and we are situated in quadrant 4, so obviously x is positive, y is negative in quadrant 4. We know that because the x value is 1/2, you could say that this is pi over 6, and so this is square root of 3 over 2 and 1/2. This is for quadrant 1, but because we're in quadrant 4, this has to be negative, the x value, the y value. And so what is pi over 6 in quadrant 4? So 5, 7, 11 pi over 6. Pi over 6 is situated here because it's nearest to the x-axis. So this is 11 pi over 6. There you go. Okay, for number 75, tangent t. So by the way, for numbers 75 and 76, we're not given either sine or cosine value anymore. So we're going to have to apply SOHCAHTOA, so that deriving from tangent, or something else that is the inverse of sine, cosine, and tangent, um, basically, namely cosecant, secant, and cotangent, you could say that you could like basically find sine, cosine, or tangent, sine or cosine from this one. Let's apply that information with number 75. So we know that in quadrant 2, uh, our x and y, our x is negative, our y is positive. And for what we have right now, tangent t is equivalent to negative square root of 3. Or we could write it as like this, negative square root of 3 over 1. Because tan in SOHCAHTOA is opposite over adjacent, we could say that what we have to look for is the hypotenuse. So just look for the hypotenuse. I hope you know what to do. It's basic Pythagorean theorem. Adjacent plus opposite side, adjacent plus opposite side, 1 plus alright. So I hope you have your scientific calculators with you. I'll just get mine. Let's solve together. Alright. Based on the calculator, the hypotenuse is 2. So right now, now that we know the hypotenuse, we could already identify what sine is and what cosine is. So sine is O over H, so, and cosine is A over H, or ka. So for sine, opposite side is, by the way, in number 75, it's quadrant 2. So based on the SATCHEL or SATC diagram, it is known that in quadrant 2, only sine and its inverse, cosecant, are positive. So this is positive. And for cosine, adjacent is 1 and the hypotenuse is 2. But then it's not, in quadrant 2, cosine is negative. So given these known values, let's bring them together. So x value is the cosine and the y value is the sine. So what we have here right now is quadrant 3 is pi over 3 in quadrant 2. The question now is, what is pi over 3 in quadrant 2? So let's illustrate. This is quadrant 2. Pi over 3 is located here, located near to the y-axis, and basically 2, 3, 5, it's 2 pi over 3. That's the answer for number 75. Let's move on to answering number 76. So secant t is equal to negative 2. T is in quadrant 3. So in quadrant 3, only tangent and cotangent are positive. So basically, x and y are negative, our sine and cosine. And so given that we have secant t, which is equal to negative 2 over 1, another way of saying negative 2, it could be said that because cosine is the secant is the inverse of cosine, cosine is like this. So by that, with that in mind, know that cosine is A over H, or ka in SOHCAHTOA. And so what we have to look for right now is the opposite side. So right now, uh, hang on. Put these values in the scientific calculator. It's safer to calculate it that way rather than manually. Um, Only except if you're really gifted in mathematics. But let's use the standard solution. Uh, so we now know that cosine is negative 1/2. So what is sine? Sine is O over H. Opposite side is square root of 3 and H is 2. And because in um, quadrant 3 explains that x and y are negative, sine is negative here. So let's combine the points together. So cosine is negative 1/2, sine is like this. And so we could say that because x is 1/2 and y is square root of 3 over 2, in general, this is pi over 3. And right now in number 76, pi over 3 is in quadrant 3. What is pi over 3 in quadrant 3? Let's identify. Pi over 3 is here. It's nearest to the y-axis. And 2, 3, 5, 7, 5, 4. 4 pi over 3. This is the final answer. Alright. Let's move on to numbers 77 and 78. Let's finish this as soon as possible to make the video not so long. Alright, I'm sorry about that. I just got bitten by a mosquito. I'm outside. Anyways, for number 77, sine t is equivalent to 1, such that t is quadrantal. If you want to know the definition of quadrantal, I cannot give an exact definition of it. I tend to just answer what's being asked without really inquiring on definitions that I don't know. So you'd be better off searching for it. But for now, let's stick to the objective. Sine t is equivalent to O over H, and because sine t is 1, you can say it's 1 over 1. So we know the opposite side and hypotenuse. Let's look for the missing side, which is the adjacent. The adjacent is 0. And so I know in actual triangles this isn't possible. But in the context of using Pythagorean theorem in this lesson on trigonometric functions, I think it makes sense. Let's just not think of this as if we're trying to make an actual triangle, because we're not. So right now, cosine t is equivalent to A over H. A is O and H is 1. So let's see, 0 over 1 is still 0. So let's gather the data. X is the cosine, so 0, and sine is the 1. So 0, 1. That's the point. In the Cartesian plane, or in the unit circle, something like that basically. You see, because x is 0, so our point is there, and let's say this is 1. And this is 90 degrees. In other words, or if you express that value in radians, it is pi over 2. Then there's so many mosquitoes right now. So sorry. Anyways, for number 78, cosine t is equal to -1, which is equal to a over h. So what we want to look for right now is the opposite side, which is basically 0. And so with that, let's look for sine. So this time sine is 0, I think. Yeah. And so make the point. So cosine is -1 and sine is 0, x and y respectively. And right now, let's see what that is in the unit circle. So -1 and 0. So right now, starting from 0, this is a straight 180 degrees, which if it's expressed in radians, is called pi. This is the final answer. I suppose that the instructions state that our final answers should be expressed in radians. But whatever your instruction is, if you're being instructed to place your final answer in degrees, then do so. Just convert from radians to degrees, or if your answer is already in degrees, then just box it. That's it for this video. I hope it has been helpful to you. Yeah, I'll see you soon for more walkthroughs on exercises about exercises that can be found in Mr. John Coburn's Precalculus textbook. Thank you for watching.